So, lesson 6.1, Skybound. A cannon is 10 feet off the ground. It launches a cannonball straight up with a velocity of 406 feet per second, which is about 277 miles per hour. It says, imagine that there is no gravity and that the cannonball continues to travel upward with the same velocity. So again, imagine that there's no gravity and it's traveling upward with the same velocity. Well, first of all, what is velocity? I encourage you to pause the video and look this up, because if you don't already know, it's important that you know. All right, so velocity is a vector. Velocity is speed and direction. So a lot of people use velocity and speed like interchangeably, but they're not the same. That's why there's two different words, two different concepts. Velocity includes speed, but it also includes direction. So for instance, if you're headed down to Dover, that is a velocity because it has a speed and a direction. So I'm headed, 60 miles south on I-95, velocity. Versus if you just don't give a direction, you don't know what direction someone's going, you just know that it's, 5 miles per hour, that's speed. All right, so imagine that there's no gravity and that the cannonball continues to travel upward with the same velocity. So upward, okay, that's our key. All right, so complete the table. Well, if it's telling me that it starts at 10, I agree that 10 should be where it's 0 seconds. And it goes up 406 feet per second. Well, these are the seconds. So I know that this is going to be plus 406, plus 406, plus 406, so on and so forth, because it's telling me that's how much it's going up per second. Sorry. So that gives me 416, 822. I might need to make my pen a little smaller. 1,228, 1,634, 2,040. And now we get to T. It says, it just gives us the variable T. So I kind of have to figure out, well, how am I supposed to do it with T? I know how to do it per second, but now it's basically saying for any second T. Well, what did I do initially? I added 406 each time. So since I added 406 each time, it doesn't matter what second I was on, it's always going to be multiplied by 406. So what I mean by that is 1 times 406 is 406. So if I put 2 times 406, I get 812. If I do 3 times 406, I get 1,218. So are we seeing something? Are we seeing something here? From here to here to here? I hope we are. I hope you're seeing that. 406 is 10 less than 16. 812 is 10 less than 822. 1218 is 10 less than 1,228. So what I'm thinking is I still have to do something with 406, and it seems like it's being multiplied by whatever second I'm at. So whatever second T. But in order to actually get the correct answer, 416, 822, so on and so forth, I have to add 10 to that. So I want to have 406 T plus 10. And now, no matter what second I choose, if it's 1, 0, 3, 4, 5, anything beyond this chart, I will get the correct velocity for how high this is it a cannonball? Yeah, this cannonball is above the ground. All right. So then it says, write an equation to model the distance in feet of the ball t seconds after it was fired from the cannon if there was no gravity. I'm just going to erase all this real quick. All right, so now it's asking, write an equation to model the distance in feet d of the ball t seconds after it was fired from the cannon if there was no gravity. Well, this question is really just asking me what we just figured out in column T. So my equation is going to be d, the distance, equals 406t plus 10. Because again, this is t seconds after it was fired from the cannon and there's no gravity. All right, and that is the warm-up.